Okay, let's take a look at what happens when we start adding odd numbers from the first one, the first few odd numbers. For example, 1 plus 3, these are the first two odd numbers, and their sum equals 4. Now, if we continue in this way, adding the first few, in this row we're going to add the first three odd numbers, which are 1, 3, and 5. So 1 plus 3 is 4, 4 plus 5 is 9. Let's do another one, just more like 1 plus 3 plus 5. So far we have 9, and then we add the next odd number after 5, which is 7. So 9 plus 7 equals 16. Let's do one more sum of these. Let's add the first 5 odd numbers. So 1 plus 3, that's the second one, plus 5 is the third one, plus 7, that was the fourth one. Now let's add the fifth odd number, which is 9 after 7. So here we have 1 plus 3 is 4, plus 5 is 9, plus 7 is 16, plus 9, 16 plus 9, now we have 25. And there is some kind of coincidence here, because, well, it's really not a coincidence, but see, all these numbers, 4, 4, 9, 16, 25, those are square numbers. 25 is 5 times 5, so this is the square of 5. 16 is 4 times 4, so this is the square of 4. 9 is 3 times 3, so this is the square of 3. 4 is 2 times 2, so this is the square of 2. And in the first row, when we had only a single number, the first odd number, just 1, if that's all we are adding, then the sum there is just 1. That's all we have. But 1 is also a square number because it's 1 times 1, so this is the square of 1. Now let's look at the relationship between the number of numbers, the number of odd numbers that we are adding. In this case it's just 1, and the sum is 1 square. When we add the first two odd numbers, the result is the square of 2. When we add the first three odd numbers, the result is the square of 3, and so on. For example, here let's count how many odd numbers we are adding, and that's 1, 2, 3, 4, and the result of their sum is 16, which is 4 square, or the square of 4. And then in the last row we have the sum of the first 5 odd numbers, and that equals the square of 5. And this keeps going. This just keeps happening. If we added the first 6 odd numbers, we're going to get 36, because 6 times 6, and so on. So let's try to summarize this in a table. So let's put here the number of odd numbers that we're adding, starting always from 1, and then let's just keep track of the last odd number in that sum and the total result, the sum. Okay, so in the first case we are adding just one odd number. The last odd number in that sum was 1, and the total sum was 1. And I'm going to write it as the square of 1. When we add two odd numbers, the last odd number is 3 in that sum, and the result is 4, which is the square of 2. When we add 3 odd numbers, 1, 3, and 5, the last odd number in that sum is 5, and the result of the sum is the square of 3. When we added 4 odd numbers, the last of them, so 4, 1, 3, 5, and 7, the last one was 7, And in this case, the result of that sum, when we add 1 plus 3 plus 5 plus 7, we get 16, which is the square of 4. Now, how do we represent this in general? Because this number keeps increasing. So if we put a letter instead of a number to represent the number of odd numbers that we are adding, then the last odd, see, notice that 3, 5, 4, 7. If we multiply, see, the odd numbers skip the even. So we have in the number line, we have an odd number and then an even number and then an odd and then an even. So it's every two numbers. So it's kind of like times 2. For example, 4 times 2 is 8. So this is not 8, it's 7. So we have to subtract 1. 3 times 2 is 6. 6 minus 1 is 5. 2 times 2 is 4. 4 minus 1 is 3, and so on. 1 times 2 is 2, and 2 minus 1 is 2. So here we just we know that the last number is going to be 2 times n minus 1. And the result of the sum is going to be the square of n, just like we did in all of these cases. And we can verify it in more cases, but this needs a proof by mathematical induction. Here, let me just write the notation. If we are adding 1 plus 3 plus 5 plus, so we write down the actual first few odd numbers, and then we just put dots to continue the sum, to make it, to indicate that the sum can be arbitrarily large, and we're going to stop with the last odd number. In this case is going to be 2 times n minus 1, and the result of that sum is the square of n. So this is one way of writing it, this result, with this notation. Another would be saying, with words, saying the sum, and then we use parentheses to indicate these two. What we're adding are the first n odd numbers, and the result of that sum equals n square. There is also this mathematical notation, sigma notation, a little bit more formal. So sigma is a Greek letter, and here we will label an index, for example k, from k equals 1 to n of odd numbers. So we are adding 2 times k minus 1. This is the general formula for an odd number, and the result of that sum equals n square. So any of these three notations, like this one or this one or this one, are just expressing the same property of square numbers being the result of a sum of the first few odd numbers. And so that's it. Thank you very much for watching, and have a good day.